This video is about the binomial distribution in calculator. So we're going to be talking about what is a binomial distribution. First of all, a binomial distribution is a probability distribution that describes the number of successes in a fixed number of independent trials. And each trial has only two possible outcomes. We're going to call them successes or failures. And the probability of success remains constant against all trials. So the way we write binomial distribution is that we say that we have an event and it has a binomial distribution. We start with n comma p. N is the number of trials, and again, one of the assumptions in order for us to consider this as a binomial distribution is that all of the trials are independent of each other. And then p represents the probability of success. So I'm going to give you a very basic example. Let's say that we're talking about basketball and we're going to be making free throws. And let's say we're going to talk about my probability of success. So if I go ahead and I make 10 free throws, I'm going to get 2 of those balls in the basket. Okay, so my probability of success is going to be 2 over 10 or just 0.2 because for every 10 baskets, I'm only making 2 of them. So that's my probability of success. I'm not a big basketball player, so obviously it's not as good as perhaps somebody else who's playing basketball. Theirs could be higher, 5 out of 10, 7 out of 10. But right now we're going to work with this example where the probability of success that I actually make a free throw is going to be 2 out of 10. So here's an example. Let's say that I'm going to be shooting 20 free throws. And I want to find out what is the probability that I'm going to make exactly 4 baskets. So this is an example of a binomial distribution because again, it is a type of probability distribution where you have failures and successes. So in this particular case, my probability of success is 0.2. So we have a binomial distribution. Out of these 20 independent trials, I have a probability of success of 0.2, and I want to find the probability that I make exactly 4 baskets. So I'm going to go ahead and go to my graphing calculator, and in my graphing calculator, I'm going to go to second vars, which is distribution. From there, I'm going to go up to option A, which is going to be binomial PDF. Now you're going to notice that there is a binomial PDF and a binomial CDF. Right now, because I want the probability that I make exactly 4 baskets, I'm going to go ahead and go to binomial PDF. So in the calculator, I'm going to go to second vars, and I'm going to go up until I get to option A, which is binomial PDF. Now it's asking me for the number of trials. I'm going to go ahead and put 20 because the number of free throws that I'm attempting is 20. P is my probability of success. Remember that I have a 0.2 probability of success. And I want to figure out what is the likelihood that I make exactly 4 baskets. So I press paste, press enter again. And that means that there's about a 21.8% chance that I'm actually going to make exactly 4 out of those 20 baskets, or a probability of 0.218. Now let's say instead I want to determine what is the probability of making at most 4 baskets. So in this particular case, if I want to find the probability that I make at most 4 baskets, at most means that I could make 4 or 3 or 2 or 1 or no baskets at all. So in order for me to find the probability that I make 4 or less baskets, I'm going to still go to second vars in my calculator, but this time I'm going to choose option B, which is binomial CDF. Binomial PDF stands for binomial probability density function. And in this case, it's going to calculate the probability of getting exactly K successes. So the last time I only wanted the probability that I made exactly 4 baskets. But this time I'm going to choose binomial CDF because that stands for binomial cumulative distribution function. And in this case, it means what is the probability that I'm going to make 4 or less. Now, one of the things that is important is if you are using the TI-84 Plus graphing calculator, this calculator is going to find the values cumulatively going down, okay? So it's going to help you find 4 or less. If you have a TI Inspire calculator, then in that case, when you go to this function, you're going to be able to put the lower bound and the upper bound. In this case, your lower bound would be 0 and your upper bound would be 4. I'm using a TI 84 Plus calculator right now. So I'm going to go to second vars. Again, this time I'm going to choose binomial CDF, which is the cumulative distribution function. I still am doing this for 20 trials. My probability of success has not changed. It is still 0.2. And right now, I want to find the probability that I make 4 or less baskets. So I'm going to go ahead and press paste, and then I press enter. And the likelihood that I make 0 or 1 or 2 or 3 or 4 baskets is 0.6296, so approximately 0.630 if you have to round to 3 significant figures. That means there's about a 63% chance that I make either 0, 1, 2, 3, or 4 baskets. And that's a pretty high probability. And the reason for it is because, remember, I only shoot 2 out of 10. So yes, it is very likely that I am probably going to make 4 or less baskets. Now, if you are better in basketball, let's say that your probability of success is 0.7. Let's look at what happens if I were to change this and put 0.7 as my probability of success. It's still 20 trials, but now 0.7, and I want the probability that I make 4 or less baskets. When I press enter, notice that's a very tiny amount because this means 5.55, and that e to the negative 6 means times 10 to the negative 6 power. And that is because the probability of success is 0.7, which is really high. And so the likelihood that if I can actually make that many free throws, that when I go to the free throw line and I have 20 free throws that I'm going to throw, the likelihood that I only make 4 or less, it's very, very tiny. It's very small because my probability of success is so much higher. It's 0.7. So as a recap of the binomial distribution, remember we write this as x has a binomial distribution of n comma p, where n is the number of independent trials and p is going to be your probability of success. We're going to use Binompdf in the calculator when we want to find the probability of a specific number of successful trials. And we're going to use binomial CDF, which is the cumulative one, when we want to find the probability of a range of successful trials. And what's really important is if you are using a TI-84 Plus graphing calculator, it's going to work for the probability of x is less than x, okay? So that's something that's really, really important because if you want to do greater than, then you have to think what would be the complete opposite. So going back to our example of free throws, remember that we were going to make 20 free throws. So we have 20 trials. My probability of success is 0.2. I want to find what is the probability that I make more than 12 baskets. I'm assuming that that's going to be a really low answer because my probability of success is only 0.2. But let's go ahead and figure it out. Now, I'm using the TI-84 Plus calculator. Those of you who are using the TI Inspire, this is easy. You go to binomial distribution, you put in your number of trials, your probability of success, your P, and from there your lower bound is going to be 13 and your upper bound is going to be 20. And again, the lower bound is going to be 13 because I'm looking for the probability that I make more than 12, and more than 12 is 13, 14, 15, 16, all the way to 20 baskets. So what happens in my case when I'm using the TI-84 calculator, I'm going to show you this in a little number line so you kind of understand the gist of what it is that we are doing. So here, if I want the probability of making more than 12 baskets, that means I could make 13 baskets or more, okay, or 14 or 15 or 16. So the complete opposite of making more than 12 is 1 minus the probability that I make 12 or less, okay? So the complete opposite of making 13 or more is that I make 12 or less instead. So that is going to be the complete opposite. Each one of these are independent trials. I'm going to go now 1 minus second vars. I'm going to go up to binomial CDF. I'm going to go ahead and put 20 trials. Remember, so my probability of success is 0.2, and I want to find 12 or less. I'm going to go ahead and put paste, and then this is really, really small. Again, I told you I thought it was going to be really small because my probability of success is only 0.2. So the likelihood that I'm going to actually make 12 or more baskets is tiny, okay? It's 1.516, about 1.52 times 10 to the negative fifth power, which is a very tiny probability. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.